Welcome to our physics class, and this is question 4, and we're going to look at the questions that we have. We are dealing in the chapter that has to deal with work energy and power. So work first times displacement, energy, ability to do work, and then power, rate at which work is done. So that's grade 12 caps. And looking at, we have a car is towed away at constant speed of 50 meters per second, and then we have force applied 1500 newtons. It's 1500 newtons, and then the angle applied is 30 degrees to horizontal, and then track is towed for 180 meters. And then from the given information, we're required to draw a free body diagram. So we have that which is weight, and we have applied force, we have normal force, and then we also have the friction. So that's normal force, that's friction, that's weight, and that's force applied. And then that's the free body diagram. And then we are given 4 marks, so it's 1 mark for each force. So you check the marks, and then you check how many forces you have. And we look at the state work energy theorem. So the work net done on an object is equal to its change in kinetic energy. So that's the meaning of work energy theorem. That's how it's stated. The next question is, use energy principle to calculate frictional force experienced by the car. So frictional force, energy principle, calculate the frictional force. So frictional force should be part of the work net. Constant horizontal speed means that work net is 0. So we have 2 forces horizontal, there's force applied and friction. All that combines to 0 because there's no change in velocity. So work net is going to be change in kinetic energy. Okay, the change in energy, the energy is kinetic, and constant V means that change in kinetic energy that is going to be 0. So the change in kinetic energy is 0. And we have work net there. So the work net is going to be it's going to be force applied cos 30 degrees cos 0. So that's for the direction. That's horizontal force, horizontal component for FA, and plus friction, but okay, multiplied by displacement with change in x, plus we have frictional force, change in x, and then we have cos 180 degrees for opposite direction is equals to 0. So that's the work energy theorem, and that there is going to be change divide by change in x both sides. Okay, and that change in x, so the displacement cancels out on the equation, so we have 0 on the other side. And now we substitute the values. So we know that force applied is 1500 newtons. Okay, and then we're going to substitute the values. 1500 newtons multiplied by cos 30 degrees, and that gives us, cos 180 degrees gives us -1. So it's going to be negative F is going to be 0. And then solving for friction is going to be 1 cos 30 multiplied by 1500, that's 1299. So that's going to be 1500 newtons multiplied by cos 30 degrees. That gives us cos 30 degrees multiplied by 1500, that's 1299.04. So it's 1299 newtons, 1299.04 newtons, and that's our final answer. So step 1. So these are the steps. Step 1, work energy theorem in equation. Step 2 is substitute the values and cancel out the displacement. 3 we solve for F, and then F, the step 4, that's the final answer. And then we go to question 5.4, where it says that calculate the work done by gravitational force on the car as it moves from B to A. So you see that so as it moves the path A, so we have B to A, so that means as it moves to the top. Okay, so BA is at the bottom and B is at the top. B is at the bottom and A is at the top. So we have that part, and then constant velocity means that the force applied is 0, and then we have friction there, and then we have constant V, acceleration is 0, and then we also look at so we look at we're looking at that graph. So that is it. So we have the path that it has to travel. This is 30 degrees, and then we have change in X there, and then we have 15 meter. So we need to know the height. So we need to first solve change in X. So sine theta is going to be opposite over hypotenuse, and sine 30 degrees is going to be opposite is 150, and then it's going to be 150 over X, change in X. So it's going to be 150, which is our height, meter over change in X. We make the left hand side a fraction as well, so we cross multiply, and we have X is going to be 50 meter times 1 divided by sine 30 degrees. So that gives us 150 divided by sine 30, it's going to give us 300. So that gives us 2 times 150 meter. So that is going to be 300 meter. And then the other thing that we have to do is work. We have work done by gravitational force. That's the FG in parallel. So we have the equation, which is mg sine mg sine theta, multiplied by displacement, and then multiplied by cos alpha being the direction of motion. And then we have the mass there. Okay, with this point A to point B, and then we have point A there, and also point B, point A and point B, and then we have 1200 kg multiplied by gravitational force 9.8 meter per second squared, and then we have sine 30 degrees angle of inclination. Displacement there is 300 meter, multiplied by a displacement which is 300 meters, and then by direction, which is cos 180 degrees. So it's cos 180, that's which motion is moving, so it's cos 180 degrees. 180 degrees, it means that the force is against direction. Okay, that's one, and then this is the other part, and then that part there 0 degrees, and it's often its opposite, and that's going to be 180 degrees, opposite motion. So that's how we get the alpha angles. So 0 or 180 degrees, one of the two, depending on the direction, if it's on favor or against the direction of motion. So calculating that gives us negative 1764000, 1764000, and that's our answer, newtons. Another thing we look at answering this question, that from, let's say it's from point B up to point A and point B up to point A, so they want to know that is it going to require the same. Yes, it's going to be the same because of same vertical height covered on both scenarios. The height is 150 meters. Okay, so the heights are the same vertical height, so which means that it's going to be the same. So that's it. So thank you so much for watching, and don't forget to follow or subscribe. And this is your tutor, Black